Yes, you do. So you're going to do the one that says 11.1. What you have to do is you have to figure out what two numbers, when you put it in for x and y, make the equation true. All right, if you'd like, you may use calculators.
I know what number one is.
Yeah, because
Algebra's on the right track. Let's see, Noah, are you here today?
Yeah. So 6.
Okay.
Wait, are you doing it? So what's better? Okay.
Adam, is Adam here? Okay.
Direction-wise, you can work individually or as part of this. You decide what you want to do.
Borrow pencil is going to cost you $80, or you can give you a Paula. We'll forget the 20 entirely. Evelyn's here.
we can drive the
Della's here. Anthony. E.
Okay.
Let me see. Is there a Neil in here?
Y equals
6.
y equals 2 and then x equals 2.
Is there Mr. Prince?
Yes, I'm trying to bring
There it is. Okay.
I just want to see it.
No, I know that.
That's not here. Yes.
Wait, is there a new kid that's coming to our class?
Okay, guys, get focused. I don't, no, they're not. Well, let's get focused. Let's get that answered.
Okay, I solved it. So x equals 1 and y equals 1.3 repeated. Because 1.3 repeated times 3 is 4.
Or,
Wait. That's it.
Do y'all know who Neil Prince is?
I know him.
x equals 0 and y equals
3 by itself is 9.
3 times 3 is 9.
Oh. You still got it. I mean, that also works.
Okay, we're not going to discuss politics right now.
Yeah, politics. If you discuss politics, that makes you get advantage. Okay.
Okay, about 2 more minutes.
So 5.
Oh my goodness.
So 5 times what? 3, okay? 5 times 3 is x. This makes 6 is 15, right? You get 15 to 9, what would you do? So what's the multiply this by?
5 minus 1/3 something.
Okay, so for number 3, I think.
Here's the problem. 5 times 0. Actually, that would work. 5 times 0 is 0. 3 times 3 is 9. Yep, that'll work. Okay, I like that.
Yes, I think
Seven for x. Okay, about 20 seconds. And we're going to go over it real quick. Okay. It's going to cost you lunch detention morning with you. All right, ladies and gentlemen. So what we had to do is we had to figure out what makes x and y We have to plug numbers in for x and y and see which one makes it true. Okay? So for number one, we have 6x equals 7y. All right? If we multiply 6 times 7, what does that equal?
42.
42. In multiplication, I believe, has a commutative property. Okay? I mixed my properties up. Can we multiply 6 and can we multiply this side by 7 and get 42? And this side by 6 and get 42? That's correct. Okay? And then for number 2, we have 5x plus 3y equals 9. Okay? So if I did 5 times 3, what does that equal? 15. Now I need to get from 15 to 9. So what do I need to get from 15 to 9?
Okay, yes.
We have to get a negative 6, right? Because 15 plus negative 6 also equal 9. So what would I multiply this 3 by? So we're going to put negative 2 in for this y variable to get negative 6. Would you agree? Okay. Would it equal 9? Yes. Okay. This third one is probably the trickiest one. Okay. So I put 3 in for y. 3 plus 5 is 8 minus 1/3 of 3. What's 1/3 of 3? 1. So 8 minus 1 equals?
8 minus 1 equals 7.
7. Okay, good. Alejandro, you have a different method? Please elaborate.
X equals 3, and then y equals
Okay.
I did it right. X equals 3, and then
So you said x equals 3, y equals 2. Well, could we put 0 in for x? Yeah, that might actually be easier. Put 0 in for x. That way it eliminates this whole fraction. Because anything times 0 equals
0.
0. And then what would you put in for y if we put 0 in for x? 2. Because 2 plus 5 is
2
7.
plus 5 is 7.
Mr. Patino, I know you had a different method for number 2. What'd you do?
I did 5. X equals 0 and y equals 2.
Okay, that works as well. Did it say which numbers we had to use? No. It just said we had to plug something in for x and y, and it had to make the equation true.
When you look at number 3 for that 1/3 x, are there certain numbers that pop into your mind that you know you want to work with? Like, so I see some head shaking. Can you talk to your tables? Like, what do you think those numbers might be?
So anything, these are a multiple of 3, I like that. Do we want to use 8 if we're talking about thirds? Probably not. What about when we're talking about fourths? Yeah, because it's a multiple of 4.
What'd you come up with at your tables? Anthony?
Came up with like every 3 times 2, 6, everything that is multiplied by 3.
Why did you get there? I think Mr. McFerrin was getting to that, but why did you guys get there? How did you guys get there?
The reason why we got there is because if the denominator is 3, we already know we can divide by 3.
Oh, so we're looking for factors of 3. I didn't mean to put those words in your mouth. We're looking for factors of 3. What does that help us do?
It helps us divide faster.
Yeah, cancel, divide, however you want to look at it, right? Yeah, that's pretty smart. Go ahead, Alejandro.
It helps us divide into a normal number instead of a fraction and a number.
So you're trying to get to a situation when you do the division that you're not left with another fraction. Right? It just makes our lives easier. Then we got to manipulate a little bit. That's fine, but we're trying to make our lives easier with dealing with those fractions, aren't we?
Another thing I want to ask you, if we just have one y, is that going to be easier to work with? We don't have to multiply. We can just use it as what I call a plug number. So for example, if I put negative 1/3 x and I put 6 in it for there, that's minus 2, correct? So then we get 5 minus 2, which is 3, and then 3 plus what equals 7? 4. Yes.